Hi, good afternoon. This is Mr. Cassidy, and today I'm going to be covering Chapter 3, Lesson 2, Y varies directly with X. And in this direct variation lesson, we're going to learn how to graph a simple line with one slope. And we're going to use input and output to help us graph. So let's get into it. First, a quick review of what we've already covered in the lesson. Previously, we've been learning about slope, and we've been learning about how to find slope on a graph. And where we left off was how to find slope with a coordinate pair. Now, there are two ways to do this. Let me go ahead and get my pen. There we are. And one way is with the formula. Some people prefer this way, so I'm briefly covering it. Now, how we use the formula, a lot of people see the little twos and the ones, and they're like a little taken aback by it. It's confusing to look at this at first. But all that means is we're assigning numbers to our points. So let's say I'm using the points 3, 6. Well, that is an x, y pair, right? A coordinate pair telling us where to graph the point. Well, since this is the first point, I'm going to call it x1, y1. That little 1 just means that those are both the ordered pair from the first point. And on the second point, it's also an xy pair. And we're going to use a little 2 to show that this is a different point. It's a new point. Now, it's okay to switch them too, because the points can be in any order. We will still get the same slope. But I just number the first one, the first point, second one, the second. And now what I'm going to do is I'm going to use substitution. So since it says y2 right here, I'm going to start my formula with the number that I labeled y2. So -1. Since there is a subtraction sign in the numerator, I'm going to put a subtraction, and then I'm going to put y1. Well, y1 is 6 in this case. On the denominator, I start with x2, which is the 5, and I subtract, because that's my formula, the 3, because that's x1. So -3. And now what we're going to do is we're going to simplify the top and simplify the bottom. -1 minus 6 is a -7. And 5 minus 3 is 2. And once I've solved that, if you still have a negative, if there's a negative on the top or a negative on the bottom, it can be rewritten in front of the fraction -7/2. That's our answer. If there is a negative on the top and bottom, so if I had -3/5, well, negative divided by negative is a positive, so our final answer would be positive. So that's the way we can use this formula. Now, some people prefer it. If you do, go ahead and copy it here, and you can use it on the next slide when we practice. But I prefer an easier way. My way is still knowing that this is x and this is y, and the next point is xy. I make a little table. I put x here and y here, and I just put those coordinate pairs together. So 4, 5 is going to be the x and the y pair here. 2, 7 is the xy pair here. And then I do the rate of change. So remember, rate of change and slope are the same thing. And that's where we do change in y over change in x, which is the same as slope, change in y over change in x. And so how I do that, I'm going to do the change in y. I go, well, 5 moves to 7. On the number line, that would be 5 plus 2 to get to 7. That's going to be my numerator. For the denominator here, I would take, go ahead and change it to light blue. And 4 changes to 2. Well, that is subtracting 2. 4 minus 2 takes it to 2 on the number line. So my denominator is -2. Since it's a fraction, I'm going to go ahead and reduce. And if I can change the pen color, I would. There we are. And I'm going to go ahead and reduce. Positive divided by negative means the whole fraction is negative, and 1 divided by 1 is just 1. -1 is the slope. Okay, your turn to try. So find the slope of a line passing through 2, 8 and 4, -2. Choose the answer on the right. Okay, you could have used either method. I'm going to use my simple method because that's the one I like. xy goes here, and 2, 8 goes here. 4, -2 goes here, and then I do the change. So 8 to -2, that would be subtracting 10. That's my numerator. And denominator 2 to 4, that is adding 2 plus 2. And I simplify. You should have gotten negative 5 over 1. All right, how about the second one? Go and solve now. Find the slope of the line. Once again, I'm going to show you on my easy method, and if you prefer using the formula, that's fine. You should still get the same answer. I fill in 1, 1 and 5, 4, and then I find the change. So change in y is adding 3, change in x is adding 4, 3 over 4 is the slope of that line. Okay, carrying on. So today we need to review graphing. In order to be able to graph a line, and that's really one of the main goals of our chapter, we need to be able to plot a point correctly. Remember, all points are written as a pair of directions, x, y. The x direction tells us to go left or right on the x-axis, which is our horizontal here. The y direction tells us to go up or down on the y-axis here. Always start with your pen at the origin and start by moving left or right, then up or down. So to graph 4, 2, I would start at the origin, that's at 0, 0. I would count 4 to the right since it's positive. 1, 2, 3, 4. Once I'm there, I'm going to go 2 up because it's positive. And that would be my first point. Let's say that that was point A. I'm going to put a little A to label it here. All right, how about 3, 7? Well, I would go start at 0 again. I would go to the right 3, 1, 2, 3. Then I would go all the way up 7. That takes me up here. It's like following directions to a house. We're just following a map, and each of these numbers tells us a way to move. How about point C, negative 3, negative 5? Well, I'd start at 0. Negative 3 on X means go backwards 3 to the left. And that's going to be, since it's negative, it's left. And then negative 5 means down 5. Okay? Negative 3 down 5 is going to take us right here. And that's point C. Okay, it's your turn to try it. On the coordinate A, what directions are you going to use, starting from the origin? Well, to get there, you should have said left 2 and up 7. That would be where point A is. Okay, try it again. With point B, what directions will take you to point B from the origin? You should have chosen left 3 and down 2. That would take us right here to point B. All right, and how about point C? Well, starting from the origin, the 2 directions we're going to follow is first to the right 4 and then down 2. C is going to be right here. Now, if you got those wrong, if you would not be able to find where to put A, B, or C, or if you're shaky on this, you may want to review it. There are many websites that I can give you that would help with that, but you really need to be solid on a graphing skill to help with this chapter. I'll provide the link here, and you can follow it on your own. So how do we use this knowledge? Oh, second bit of review. So let's say we have a problem like find negative 6x when x is 2. Well, what that means is I'm going to put 2 where the x is and solve it. So it was negative 6 times x. That means negative 6 times 2 is negative 12. I need you to practice plugging in what x is. This is called substitution, and we're just substituting the number for the x. So find 5x when x is 10. You should have chosen that 5x would be 50 because we would do 5 times 10 and get the answer 50. All right, find 2x when x is 3. You should have gotten 6 because 3 would be multiplied by 2. 2 times 3. We put the 3 where the x is. How about find negative 1/2 of x when x is 4? You should have chosen negative 2. And the reason why is we do negative 1/2 times 4. And we can make that a fraction, 4 over 1. Multiply straight across, negative 4 over 2. And when I simplify that, I get a negative 2. Okay, this is our second skill we're going to need to be able to graph, and I hope that helped us review it. So here's how we're going to graph an equation that is directly proportional. You may want a piece of paper out for this to take some notes and to really understand how to do this. Let's say we have a situation like this. Isaac gets $8 per hour doing yard work in his neighborhood. How could you write that as an expression? Well, I hope you came up with something like 8x, because yeah, 8 times x, and x is the number of hours he works. That would be an expression to represent Isaac's job. So let's turn that into an equation. What if I change that to y equals 8x? Well, here the y is going to mean his total money, how much money he has. He still makes $8 per hour. And notice we're now working with equations with two letters in them. This is what's new, and this is a main idea in 8th grade math, is what do we do now that we have two letters? Well, his total money depends on how many hours he works. So that's why the amount of money can change, the y, and it changes based on the x, how many hours he works. You put in the number of hours he works, and you could find out how much money he makes. So let's fill in this table together. Here's my equation, y equals 8x. Well, if x was 0, if he works 0, this is the hours. This is his total money. If he works 0 hours, he would get $0. How about if he worked 2 hours? Well, 2 times 8 would be 16. 4 hours would be $32. 6 hours would be $48. And 7.5 hours. Well, how are we going to do that? Well, I guess I could just put this where the x is. Y equals 7.5 times 8. And I flip-flopped those. The 8 could go in front or afterwards. And 8 times 7.5, well, that's going to be, let's see here, 54, 56. I believe it's going to be $60. So let's find the slope of this line based on the table. Find the change in y over the change in x. Well, on the table you should go, okay, goes up 16 and up 2 on x. When I make a fraction, rise over run, 16 over 2, our slope is 8 over 1 when we reduce it. Now, what does that slope mean in this problem? Well, he gets $8 for every 1 hour of work. And that ratio allows us to create a graph of the problem. How I'm going to do that is I'm going to graph the coordinates that I already found. Let me go ahead and label 0 is right at the origin, and I'll just go 1 hour, 2 hour, 3 hour, 4, 5, 6. And I do like to label, since x was our hours, I'm going to go ahead and put hours on the x-axis. And his total money is y. Total money is our y-axis. And here I'm going to need to skip. I'm just going to go by tens. 10, 20, 30, 40, 50, 60. Now you might be like, well, how do I graph this? So let's turn each of these x, y's into coordinate pairs. So the first one, when x is 0, y is 0, well, that's pretty easy to graph here. I'm going to go ahead and change the color if I can to green. Okay, 0, 0 is going to be right here. But how about the point 2, 16? Well, 2 is here. I go to the right 2, but now I need to go up 16. But notice that the intervals were by 10. So you're just going to have to estimate. And sometimes this is a skill we have in graphing. I go to the right 2 and up 16. And I'm just going to put the dot about there between $10 and $20. Okay, how about at 4? We have 4.32. That's going to probably be about there. And we have 7.5. Well, that's somewhere over here, 60. That'd be about there. Here's 7. Here's 7.5, right? Would be directly in between. And notice what this is forming. It's forming a straight line. I know I can't do that the best on this tablet, but we have graphed a straight line, and this line represents his income every hour he works. Businesses use information like this to plan how much money they're making, to plan how much money they're spending. This kind of a linear graph gives us a quick visual of what money he's going to have any time of working. So that gives us the overview of how to do this. Now let's get into the steps. So let's say we have a two-variable equation like y equals 3x. How can we graph that? Let's make a table. So our rule, sometimes I add the rule in the middle. It's sort of a brainstorming step. And that means I'm going to do the math where I do 3 times whatever x is. And you just pick some simple numbers for x. Pick 0, 1, 2, 3, or 4. So 3 times 0 is 0. And that coordinate pair is going to be 0, 0. Next, let's go ahead and do when x is 1. 3 times 1. Go ahead and find the y coordinate when x is 1. You should have chosen that the y coordinate here was 1. Okay, when x is 2, I do 3 times 2, and I would get 6. When x is 3, I do 3 times 3, and get y is 9. And here, b, I want you to do the last one. When x is 4, what do you get? You should have gotten 12. Great. So let's go ahead and turn those into some coordinates. So 0, 0 I've already got. How about if I, sorry, that means I skipped C. How about D? When x is 1, what's the coordinate pair created? You should have chosen 1, comma, oh, this should be a 3. I must have done some poor math just a minute ago. That should be 1, comma 3 to graph it. So let me go ahead and put, here we have just 1, 2, 3, 4, 5, and 6. And here I'm just going to go up by ones here so we can graph this simple line. All right. So when x is 0, y is 0, that's the coordinate 0, 0. When x is 1, y is 3, that's going to be here. When x is 2, y is 6, it's going to be here. When x is 3, y is 9. And when x is 4, y is 12. Do I have room for that? 10, 11, 12. I do. There's the graph of this equation. Y equals 3x. Notice that it's steeper than the last one we did. It looks steeper, but remember the last one we skipped by tens on the x-axis, whereas this one we just went up by ones. Now it's your turn. So here's our rule for x. I want you to figure out what would be written here. It should be 4 times 0. And I want you to figure out what the y value is. 0. And let's turn that into a coordinate pair. 0, 0. All right, how about when x is 1? Go ahead and fill in the rule. 4 times 1. And go ahead and find the y value. 4. Go ahead and write that as a coordinate pair. It always goes x, y, so 1, 4. All right, let's continue. I'm going to start skipping some of these steps because they do get repetitive. Imagine you do the rule. What's the y value when x is 2? You should have come up with 8. 2, 8 is our coordinate pair. How about, again, skip the rule here, imagine or do it in your head. What's the y value when x is 3? Okay, y is going to be 12. And go ahead and write a coordinate pair there. You should have come up with 3, 12. And last, again, you could do the rule in your head. What's the y value when x is 4? Okay. Y is 16. And so we'd get 4, 16. Now, I've already got the intervals chosen on the graph, so we have to use them. Here's 0, 0. And you would follow your directions to just graph this. 1, 4, that's going to be about here because it looks like that line is 5. 2, 8, about here. 3 comma 12, about here. 4 comma 16 is about here. And that creates a straight linear graph. So what have we learned? We've learned that if we have an equation y equals, I'm going to write the letter mx. The letter m tells us what to multiply, and that will give us the y coordinate of a line. And using that, we can use those directions to graph on a graph. All right, guys, your next job is the Edge-Elastic assignment that was assigned last week. We've gone over everything now. It's about 14 problems long, and that is due tomorrow. I thank your minds and your hearts, and I wish you a wonderful afternoon. Bye.